Okay, so for the second part of our walkthrough of the Easter homework, we're on to the simultaneous equations now. So I've got 3x plus y equals minus 4. 3x minus 4y equals 6. Now there is two methods. There's either substitution or elimination. For this one, the easiest way is to actually do elimination. Because my 3x and my 3x are the same coefficient, then I can just take one of these values away from the other. I'm going to do a minus sign here and I'm going to do a big line underneath. If I did 3x take away 3x, I've got 0. If I did y take away 4y, I'm just going to put that over here. Y take away 4y would actually give me 5y, because remember a minus is a plus. So I've now got 5y, and now I've got minus 4 take away 6. 5y equals minus 4 take away 6 is going to be minus 10. We can all solve this equation. This equation is now y equals minus 2. Now that we know y equals minus 2, I'm going to sub that back into my first equation. So I've now got 3x plus minus 2 equals minus 4. I apologise for my bin men making up noise outside. 3x plus minus 2 equals minus 4. Let's rewrite that as 3x minus 2 equals minus 4. We can all solve this equation. So that will give us 3x equals minus 2. And that means x equals minus 2 over 3. Now, for those of you who got that, and a fair amount of you did, really well done. It's not the nicest numbers having some negatives, but we've got the simultaneous equations and we've got the method. A lot of you also had the method, but just got some calculations ever so slightly wrong. I'm going to move on to the next one now, which is another simultaneous equation question. This time we have got 3x plus 2y equals 36. We've got 5x plus 4y equals 64. Now, there is no coefficients that line up. However, you can see that if I doubled this, we would have 4y here and 4y here. So what I'm going to actually do is rub that out. Well, not rub it out, but cross it out and double it instead. I'm going to do 6x plus 2y equals 72. Now that I have, sorry, not 2y, that should be a 4y because I doubled it. Now that I've got these two equations, I can do one of them take away the other. In fact, I'm going to rub this out and put it on top because it's an easier equation to take away if I do this one take away that. So now I've got 6x minus 5x is going to be x. 4y minus 4y is going to be 0. 72 minus 64 is going to be 8. X equals 8. That was easy. Now I can substitute that back into my equation. I am actually going to go back to the equation that I crossed out just because it will have the smallest numbers. So I've got 3 times 8 plus 2y equals 36. What is 3 times 8? Well, that's 24 plus 2y equals 36. 2y equals 12. Y equals 6. Okay? Can we see the process? Once you've got one, it's just substituting in and getting the other one. So I think we have one more simultaneous equation to do. Now this one is probably the hardest, and I would say it's the hardest because it's not easy to initially go for elimination. So I would actually go to substitution for this. I've got 2x minus y equals 13 and x minus 2y equals 11. Now I'm going to do substitution for this. So I'm going to rearrange this second equation to just get x. I'm going to rearrange this into x equals 11 plus 2y. Now that I've done that, I can put this into my first equation here. So I've got 2 lots of 11 plus 2y minus y equals 13. I have now got, if I expand and simplify all of this, 22 plus 4y minus y equals 13. We're getting more and more like something we can solve here. So 22 plus 3y equals 13. We can solve this equation. This is what we've been doing before and this is what we know how to do. So if I take away some numbers, I've got 3y equals minus 10, y equals minus 10 over 3. Not the nicest of numbers, but a number that we can work with. Now I'm going to substitute this number back into one of my first equations, or I can do the whole rearranging again. If you have got as far as getting this, you should be able to work out that y, I believe, was minus a third. I haven't actually got space on my whiteboard, so I'm not going to do it, but x should be minus 1 over 3. This was probably the hardest question that you could have had on the sample exercises, so if you couldn't do that one, I understand why, but for those of you who got it, very well done. Now, the last question was a worded question. However, it was just still a simultaneous equations question. So a cinema sells adult tickets and child tickets. The cost of 3 adults and 1 child is £30. The cost of 1 adult and 3 children is £22. If I wrote that out as an equation, it's just another simultaneous equation. So again, we can either substitute in or we can multiply up to eliminate. I'm going to multiply this second one. I'm going to change this to 3a plus 9c equals £66. Now I can do this equation, take away that equation. So I put it underneath. If I put it underneath, it makes it easier to do my subtraction. If I substitute one from the other, I've now got 8c equals £36. So c is going to be 36 divided by 8, which is going to be £4.50. I now know my child's ticket is worth £4.50. If I put this value back into my first equation, which was this one, 3a plus 1c equals 30, I'm going to have 3a plus £4.50 equals 30. Take that away, I've got 3a equals £25.50, and then a is going to be £8.50. So again, it's another simultaneous equation, but it's just about setting it up and finding the answers. Unfortunately, I didn't realise for you guys that the last question didn't show up when I uploaded it. So it's fine if you didn't get that. I'll get onto that at another point and I'll make sure you learn it. But hopefully, going through that has made it a lot easier for you all to understand.